All right, so we've already taken a look at some chemical equations previously in the class. Let's just go ahead over chemical equations and just point some things out. So for example, here we're going to take a look at the combustion of methane, which is CH4. So it's going to be CH4 combining with two molecules of oxygen, both of these in gaseous form, to form carbon dioxide as a gas, and then two waters as a gas. So let's just point out different parts of this chemical equation. So on the left side, these are our reactants, right? And then on the right side are our products. And then in the middle, we have an arrow. Maybe you notice some other stuff in the arrow, either above or below. Maybe you'll see a triangle sometimes. That just means that you're going to add heat to it. So anyways, the reactants turn into products. We also have these little subscripts right over here. In this case, they're all G for gas, but this describes the phase of the compound. So if it's a G, it's a gas. If it's an L, it's a liquid. If it's an S, it's a solid. And then finally, if it's an AQ, it's an aqueous solution, which means that it's dissolved in water. Right, and we're humans, so we live on Earth, so water is a very big deal for us, so it gets its own little symbol. A lot of things dissolve into water. Up front here, this 2 right here, this is the coefficient. And that just tells you how many of that compound that you have. So in this case, we have 2 O2s. So we have one O2. The Lewis structure looks like that. And then we have another O2. So in total, we have 4 oxygen atoms, but only 2 molecules of O2. If there's no coefficient in front, that means that you have a 1 there. And the 1 is generally omitted. So if there's no number in front, that means that it's actually just a 1. And the key thing with equations and chemical equations is that they must be balanced. And what that means is that everything on the left side must appear on the right side. We cannot create nor destroy matter. We can just rearrange it. So for every atom that exists on the left, the same atom must exist on the right. So I'm just going to rewrite the chemical equation. CH4 plus 2O2, and then goes to CO2 plus 2H2O. Right, and again, it must be balanced. So let's go ahead and check that this equation is balanced. There's different ways that you can format this, and you can use whichever one you feel best with. For example, you could have reactants over here and then products over here, and then you can list your element, right? Carbon, hydrogen, oxygen, that kind of thing. That's one way to do it. The way I like to do it is to have each individual atom by itself. So we'll have carbon over here, and then I'll make 2 rows. On the left side, I'll have talking about the reactants. And then on the right side, I'll be talking about the products. And then we just look through our chemical equation and see which elements we have, right? We have the carbon, we've got the hydrogen, and we've got the oxygen, right? Those are the only 3 elements here. Let's take a look at carbon. On the left side, we've only got 1 carbon from the CH4. On the product side of things, we only have 1 carbon from the CO2. Next up, we have hydrogen. We have 4 hydrogens from the CH4. And then on the product side, we have 2 hydrogens in each molecule of water, but then we have 2 molecules of water. So we have 4 hydrogens there. And then finally, oxygen. On the reactant side, we have 2 O2s, which is 4 total atoms of oxygen. And on the right side, we have an O2 there, and then we have 2 waters over here, which adds up to a total of 4 oxygens. And so what we can see is that this equation is indeed balanced. And then here's just a pictorial representation of the same thing, right? You can see we have one molecule of methane, CH4, reacting with two molecules of O2 to form one CO2 and then two waters. And then if you count up the amount of atoms on each side, they're the same, and that's always has to be true. Our equations always need to be balanced.